we start with Bohr's atomic model. First of all, he gave some important points to the theory, and the important points of any of the theory are called its postulates. So we are going to discuss the postulates of the Bohr's atomic model. The very first postulate was, he stated that the electrons in an atom revolve in a fixed circular path, meaning the energy of the electron while revolving in that circular path is always constant. Meaning in an atom we have the nucleus, which occupies a very small volume, which was already discovered by Rutherford, and the electrons are able to revolve in a fixed circular orbits, and these all orbits were named as stationary orbits. They were named as stationary orbits. The reason they were named as stationary orbits or shells is, first, the energy of electron while revolving in this circular orbit is fixed or constant. Secondly, the radius from the nucleus of this orbit is also fixed or constant, and that is why they were named as stationary orbits or shells. Now, with this first postulate, which drawback of Rutherford gets eliminated? The spectrum thing and the collapsing thing. Actually, spectrum thing नहीं discuss होगा, पहले collapsing की बात करते हैं. So, in case of Rutherford, the drawback was, while revolving, the electron actually loses energy and will follow a spiral path. But in this case, he is already saying that until the electron is present in a particular orbit, the electron energy is going to remain fixed or constant. So because of that, it will not be revolving in the spiral path and will collapse into the nucleus. So that drawback, which was related to Rutherford's atomic model, gets eliminated. Is that clear? Secondly, the second postulate, he stated that as we move away from the nucleus, the energy of the electron will go on increasing. The energy of the electron will go on increasing. Now, how that goes on increasing, we have the mathematical expression, we have the values which we are going to discuss with respect to Bohr's only. But as of now, remember that as we move away from the nucleus, the energy of the electron is going to be increasing. And also, these stationary orbits were given the names as K, L, M, N, O, and so on. The first orbit was named as a K orbit or K shell. Second, L, third, M, and continuous. Okay? Also, the N value indicates the number of the orbit or number of the shell, and the first shell is actually called as the ground state. It's called as ground state. Okay? Coming to the third postulate. Third postulate states that the angular momentum of an electron. Now, it's a physical quantity. First, let's understand what is angular momentum. Any idea about it?
So I've read a little bit about it. I don't exactly know, something to do with subatomic particles and the energies and the polarities.
But how do you define the angular momentum? Okay. If I have any particle, any object or a particle which is revolving in a circular path and having a mass m, and the distance from the center is its radius, and it is revolving with a velocity v, which is tangential velocity, meaning measured along the tangent, then the angular momentum is the product of mass, velocity, and the radius. mvr is called as the angular momentum. An object of mass m revolving in a circular orbit with a velocity v at a distance of r from the center, the angular momentum of that object will be m into v into r. Okay? Now, here Bohr states that the angular momentum of the electron is always an integral multiple of h by 2 pi. Now, this is something very important. It is always an integral multiple of h by 2 pi. Where this h is called as Planck's constant. Is named as what? Planck's constant, and it has a constant value of 6.6 into 10 power minus 34 joule second, to be remembered. Planck's constant is 6.6 into 10 raised to minus 34 joules second. Okay? Now, what does it mean? The n value is basically ranging from 1, 2, 3. They can take integer values starting with 1. Okay? One second. So MVR is equal to NH upon 2 pi, meaning it can take the values of 1H upon 2 pi or 2H upon 2 pi or 3H upon 2 pi or 4H upon 2 pi only. It can't take any intermediate values like 0.5H upon 2 pi, 0.9H upon 2 pi. Those values are not possible with respect to the NH upon 2 pi. Now why it is so?
Planck's constant is the smallest wavelength.
No. Planck's constant is not the smallest wavelength. We'll discuss.
Planck's constant like similar or like in relation to a Planck instant, which is the shortest possible time period that can be calculated in the universe.
It's related to the photon energy, if you have heard. The light radiation is emitted in the form of packets or bundles of energy, and each packet or bundle of energy is equal to the photon energy, which is given by h into nu. ठीक है, anyways, we'll come to that. यहाँ तक समझा? अब, very importantly, in the first postulate, Bohr stated that till the electron is revolving in a fixed orbit, the energy is always fixed. Correct? But let's say if the energy to this electron is increased or the energy to this electron is decreased. Meaning, if we supply the energy to the electron, can it remain in that particular orbit now? No, because Bohr ने क्या बोला कि जब तक इलेक्ट्रॉन एक फिक्स्ड ऑर्बिट में रहेगा, its energy is going to be constant. But now if I supply the energy of the electron is going to be increased. And also I stated that the energy of the electron is increasing from the nucleus. So by the supply of energy, the electron will now jump into the higher energy depending what amount of energy is being supplied. Okay? On the same lines, if the energy is decreased, matlab, let's say electron radiates some energy, loses some energy, then on the loss of energy it will jump in the reverse manner, that is from higher energy to the lower energy. Yes.
So isn't this a principle for particle accelerator? If the energy is increased externally, then the electron will shift.
If the
energy is increased, the electron will shift. Isn't that the principle of a particle accelerator? Because you're adding a force from the outside.
It's similar to that, because when you are adding the energy, it can't remain in that particular state. It has to jump to the higher state. On vice versa, when you release the energy, when you lose the energy, the electron will jump into the lower state. So it is related with that. So now, what happens is when the energy is increased, it will jump from lower n to higher n. And vice versa, when the energy is lost, then it will jump from higher n to lower n. This particular process of jumping is named as excitation of electron. It's called excitation of electron. Okay? Now, it states that whenever it excites either from lower to higher or higher to lower, the difference in the energy, delta E, which is equal to E of N2 minus E of N1, which is energy of the higher state, any N2 state, minus energy of the lower state, any N1 state, is always equal to H into nu. We write nu as this. What is nu? Nu is frequency of radiation. Frequency of radiation. Okay? Now what does it actually mean? When we talk about light energy, the radiations are in the form of packets or bundles of energy, meaning it is quantized in the form of small packets of energy. Each small part of that energy is actually called as the photon energy, which is represented by H into nu. And that light energy is always going to have some wavelength also, and it will be moving with a speed equal to speed of light. Correct. So this nu is actually the ratio of C by lambda, where C is the speed of light, which is 3 into 10 to the power 8 meters per second, and lambda is the wavelength. Lambda is what? Wavelength. Correct? So this difference in the energy would be further given as H, C by lambda. H is Planck's constant again, having this constant value, into nu, which is frequency of radiation, and it's given by the ratio of speed of light to the wavelength, c by lambda. So h nu could be written as hc by lambda. Now understand a very very important thing. The second drawback of Rutherford, how is it getting eliminated through the Bohr's atomic model? Okay? When we talk about the energy levels, if I write E1, E1 is the energy of electron in the first orbit, E2 would be energy in the second orbit, third, fourth, and so on. Okay? Now, all these energy values are constant. They are fixed values as per the first postulate. Correct? Now, if these energy values are fixed values, the difference in the energy will be fixed. On the other hand, H into C is fixed. Matlab this lambda is going to be fixed. Matlab for any two difference in the energy levels, the wavelength will be a fixed value. Matlab there are going to be only finite values of wavelength which are possible with respect to the excitation concept. Correct? This particular concept of having the finite wavelength values is called as quantization. It's called as quantization. I explained you in a very simple manner. Quantization क्या होता है? Whenever any property or parameter has some fixed values defined, then that particular fixed values range is called as quantization. And we say that parameter is quantized. So coming back to this, when I see the energy values E1, E2, E3, E4, they are fixed values. With respect to them, the difference in the energy is a fixed value. Hc on the other hand is a constant. So lambda is going to have the fixed definite values. Correct? Now based on this, if I talk about the difference in the energy levels and the wavelength, because the wavelength is having fixed values, if I now talk about the spectrum for an atom, it will have only few lines defined for the positioning of the electron. Meaning now the spectrum which will be obtained through the Bohr's atomic model is going to be discontinuous, and it's not going to be continuous, because what Bohr said, that electron is present in entire space available from the nucleus till the valence shell. So in this case the spectrum will be somewhat like this. But now with the quantization concept of definite values of wavelength, the values are going to be fixed and it will be present at particular distance from the nucleus. Now I'll not get this type of spectrum, I'll get somewhat this type of spectrum. So that is the concept of atomic spectra. Clear? So coming back to Rutherford's atomic model, two drawbacks get eliminated through the Bohr's atomic model. First was electron revolving around the nucleus and following a spiral path. Here it is not possible because the energy of the electron till it remains in a specific orbit is always going to be constant or fixed. मतलब जब तक इसकी energy constant रहेगी, it is not going to change. It is not going to jump into higher or into the lower energy shell. Obviously with the first level, which is the ground state, only the possible part is the jumping to the highest state, not to the lowest state, because this is the lowest and also called as the ground state. Clear? समझ में आया? ठीक है? Now let's talk about some mathematics related to this Bohr's atomic model, which is something very important to understand the values related to the energies, radius and velocity, the three parameters. ठीक है? Now let's understand this with the help of hydrogen atom. So Bohr actually carried out the experiment only with respect to the hydrogen gas. Okay? And for hydrogen gas, we know that H2 consists of two hydrogen atoms. Now what was this experiment related to? Let's understand. First of all, if we pass the light through a prism, what happens? Scattering. What is that process called? Dispersion. It will disperse into the 7 different wavelengths of different colors. Correct? Now why that dispersion is happening?
Different speeds.
Different speed. It's not different speed.
Velocities of the different wavelengths of light.
It's because of the different frequency and different medium and also different wavelength. Okay, so speed is same or variable?
That depends on the medium.
So if the medium is air,
Then it's the
same. How much?
3
Speed of light. Correct. So through the hc by lambda expression, this c is fixed, h is fixed. Only thing is lambda, which is variable if the medium is considered to be air. Correct. So when you pass the light, the dispersion happens because the white light is made up of 7 different wavelengths. So it gets splitted into the 7 different wavelengths. And on the other hand, if we actually observe a band of 7 colors. That band of 7 colors is nothing but Vibgyor or the 7 lights which we are observing through the white light. Correct. So now understand this. What Bohr did is he took the hydrogen gas molecule in an evacuated container. Okay? And he applied some electrical voltage to it. Applied some current or electrical voltage to it. Now by applying the voltage to this hydrogen gas molecules, what will happen? It will get excited. Why it will get excited? Because the energy is supplied. So again, moving to the first postulate, when the energy is added to the electron, it will get excited from the lower to higher state. Correct? So rule 1, when you supply some energy to the hydrogen gas molecules, the atoms in the hydrogen, the H atoms in the hydrogen gas will get excited because these gas molecules will absorb some energy, and because of that the excitation would get possible. Now this excitation will result into the movement of the electrons, because when the excitation is happening, the electrons are jumping. Correct? So it can jump to the higher energy level depending on the amount of energy being absorbed. Correct? Hydrogen has only one orbit. Perfect. So if I talk about the first orbit, the electron which is present in the first orbit, there are other orbits which are present but electrons are not there in that particular orbits. So what will happen is, you will visualize the hydrogen as this only, having one electron. This is hydrogen atom. But the other orbits are vacant, na? There are presence of the other orbits, but they are vacant. See, what happens is when the energy is absorbed by this electron, it will have the tendency to excite and move into some higher levels. But that excitation is short-lived. Matlab, the moment it gets excited, it can't live for long period of time. It will immediately come back to the ground state. Because hydrogen का एक ही state है, and that is the first orbit or the ground state. So what actually is happening with the hydrogen atom gaining the energy, the electron in the hydrogen atom gets excited, and because of the excitation it will move to the higher energy levels, but ultimately because that excitation is short-lived, it will fall back to the ground state. Correct? So these electrons which are moving over here, when they are passed through the prism, through the prism we were getting different wavelengths and bands which were observed on this photoelectric plate. Correct? Now, this particular values of the wavelength are defined with respect to the difference in the energy. Correct? So, let's say if the electron absorbs energy equal to this particular orbit, the difference in the energy will be defined as E2 second orbit minus E1 first orbit, and that is going to be equal to hc by lambda. So, here the lambda will have some fixed value. Correct? Now, if the difference in the energy is small, the wavelength will be. How is delta E and lambda? So, if the difference in the energy is small, the lambda would be very large, and vice versa. If this energy difference is large, the wavelength will be small. Correct? Okay, so consider a case where the hydrogen atom has the electron getting excited into the higher levels. Case 1, second level, so difference will be E2 minus E1. Case 2, third level, E3 minus E1. It will fall back to the ground state only. Then third case, E4 minus E1, and so on. And for every case, I'll get some values of the wavelength. Correct? Now because of that, the actual spectrum which will be observed over here will be somewhat like this. You will get multiple lines at every level or at every shell. First orbit, second orbit, third orbit. because there is a possibility that electron can jump from the higher to the lower second level also, third level also, and depending on that we can derive an expression for them.